Lesson is 9.1.2 Arithmetic Series. Now, here's a question posed way back in the day. Find the sum of integers 1 through 100 without using a calculator. So, this question was posed to a famous mathematician named Gauss while he was in elementary school by his teacher, and this was posed simply as busy work. If we were to do this as busy work, we'd take 1 plus 2 plus 3 plus all the way plus 98 plus 99 plus 100. And this would take us quite a long time. But Gauss was an extremely smart student and became a famous mathematician, and he solved this extremely quickly. So quickly, his teacher did not believe him that he was able to solve it. So what he did, he looked and he said, well, I've got 1 and I've got 100. So 1 plus 100 equals 101. Well, 2 plus 99 is 101 as well. 3 plus 98, well, that equals 101 as well. He could do this from each pair of numbers, adding the first number in the sequence to the last, the second number to the second to last, etc. And what he noticed was he had 50 numbers that when added together equaled 101. So 50 times 101 equals 5,050. And this, in fact, is the solution to 1 plus 2 plus 3 all the way added up to 100. So he was later able to generalize this formula. So in our series of n terms, the sum of the first n terms in the series is equal to the number of items we have in our series multiplied by the value of the first term in our series plus the value of the nth term in that series, all divided by 2. And if we were to look what Gauss did in this example, well, there was 100 terms in his series. 101, well, he found that by adding our first term of 1 to 100, and then he just simply divided it by 2, and that gave us 5,050. We now know this as the arithmetic series formula, where Sn equals n times u1 plus un, all divided by 2. N in this case is the number of terms, u1 is the first term, and un is the last term. Now, let's do an example. Find the sum of the first 75 even numbers starting with 2. So, I have my arithmetic series formula, Sn, and then I know how to find un. Un equals u1 plus the amount of terms I have minus 1 times the dilation. Well, let's start by just plugging in what we know into our Sn formula. So S of 75, because I have 75 terms, equals 75 divided by 2. And now it tells me my first term is 2, so I know u1 equals 2, but I still don't know un yet. So un, I've got 75 terms, so that's going to be u of 75 I'm looking for, equals u1, which we know equals 2, plus our 75 terms minus 1, and these are all even numbers, so our dilation here is 2. If I were to do all this, well, 2 plus 74 times 2, that equals 150. So I could fill in my un equaling 150, then 75 times 152 divided by 2, well, that just equals 5,700. And that is my final answer for the sum of the first 75 even numbers starting with 2. Now here, I'm asked to find the sum of the first 40 multiples of 4. Well, I know my arithmetic series formula. So S, the number of terms I'll be looking at is 40 terms. Well, that's going to equal 40 divided by 2, multiplied by, well, U1, starting at 4, plus UN. Oh, I don't know UN yet. So I have to go back and find UN, which is U of 40 equals U1, which equals 4, plus, well, we have 40 terms minus 1, and these are all multiples of 4. We would find then U of 40 equals 160. So we can put U of 40 in as 160 in our arithmetic series formula. Now 40 times 164 divided by 2, that equals 3,280. And that is the answer to the sum of the first 40 multiples of 4. Now our last example here is written in sigma form. So we look at this and we can read this as the sum of 3n minus 5 where n equals 20 to n equals 75. Well, if we go back and we look at our arithmetic series formula, we note we need U1. So we need U when n is equal to 1. So that's the first thing we must do. So I will rewrite this as the sum of n equals 1 to 75 of 3n minus 5. But now I just added when n equals 1, when n equals 2, when n equals 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and when n equals 19. So I need to subtract out these terms I just added in. So this is the sum from when n equals 1 to when n equals 19. And this is because 20 through 75 are in our series. When I rewrote it as 1 to 75, I added in these terms that I do not want to look at because that would change it from the original question. So then this would still be of 3n minus 5. Now, after changing it in the form, I see both of these parts of this. They're in sigma notation, but they both start at 1. So, since I can find U1, I can use my arithmetic series formula. So, initially, my n would be 75 multiplied by, well, U1, 3 times 1 minus 5 is negative 2, plus UN, well, n in this case is 75, so 3 times 75, well, that's 225 minus 5, just 220, and all this is just divided by 2. First part's done. But now I'm subtracting away this second sum. Once again, I'm going to use my arithmetic series formula. So now I'm just going up to when n equals 19. So I'll have 19 multiplied by, well, U1, still just 3 times 1 minus 5, which is negative 2. And now I need to add when n is equal to 19. So 3 times 19 minus 5, that's going to equal 52. All of which is still divided by 2. Finally, I can subtract these two terms from one another and find my final answer is 7,700. And 7,700 is the sum from when n equals 20 to n equals 75 of 3n minus 5.